Hi, welcome back to Physics 145 tutorial solution. We will discuss all the questions that I gave you last week, I believe. Question number 1. A car is driven 200 km west and then 80 km southwest. What is the displacement of the car from the point of origin? So for question number 1, first one is 200 km west. Okay, 200 km west. Let's say I use, I don't go to scale. So this one is 200, let's say. Right, so this is our west direction. That is the displacement. So displacement, I will use this symbol. Displacement number 1 is 200 km west. And then southwest. Southwest will be 80 km southwest, 45 degree roughly. Okay, 45 degree roughly. So that is about that distance. I don't go to scale again to mention that. So this is your S2 equal to 80 km southwest. So that means this angle here is 45. Okay, so this one is 45. So that means making this one 135 degree because the total had to be 100. What we call that, 180. Okay, so this is your starting point initial, this is your final point. Remember the resultant, the question asks for what is the displacement of the car from the point of origin. Displacement will be the starting point go to the final point. So we need to draw another vector from here go to here. So that is your resultant vector. I'll just call it S. Okay, so this one means S1 plus S2. You cannot simply sum up 200 and 80. So that one will be distance. But displacement is a direct or the shortest possible path between the starting point and the ending point. And there are two things that you need to calculate. Number 1 is the magnitude and also the direction. The direction normally refer to the first vector that you draw. This is the first vector that you draw, so I will call this one alpha. So what is the formula that we can use to calculate the magnitude of S? So since this one is not 90 degree, we cannot use Pythagoras theorem. So we have to use what we call that, cosine rule. Okay. So our cosine rule states that if you have a triangle, something like this. Okay. So let's say you have A, B, C, and you know this angle theta. So the magnitude here, A square is equal to B square plus C square. Okay, and then minus 2BC cosine theta. Okay, so the square of this one is equal to the square of B plus square of C and minus this component. Okay, and if this one become 90 degree, your cosine 90 is equal to 0. So you can see that that whole thing become Pythagoras theorem. Okay, so now we are using that one to calculate our magnitude. Okay, calculate our magnitude here. So our magnitude will be S. So we call this one S. So there is a S square is equal to S1 square plus S2 square minus 2S1 S2 cosine 135. Okay, 135. So we put in the value. That one is a 200 square plus 80 square minus 2 times 200 times 80 and then cosine 135. So we have this, later on we square root the whole thing. So now I'm going to calculate 200 square plus 80 square minus 2 times 200 times 80 times cosine 135. Okay, so we have this and then we square root the whole thing. We get 263 kilometer. Okay, 263 kilometer. That one is the magnitude and the direction will be alpha. So another one now is we are using sine rule. Okay, our sine rule. Sine rule is the ratio of the side. Let's say again the same triangle that we are using here. We refer to the same triangle, and let's say we call this one alpha, and this one, oh sorry, this one alpha, this one maybe something else. We call this one beta. Okay, so our according to sine rule, sine alpha, this angle, sine of this angle divided by the opposite side b must equal to the sine beta over the opposite side, which is c, and also must equal to the sine theta over the opposite side a. Okay, you can actually put them upside down like this also. B over sine alpha equal to c over sine beta equal to a over sine theta. Is the same ratio, except the value will be different. Okay, so now we're going to use the same sine rule. We solve the question here for the sine alpha here. So this one is from cosine rule. So every time you write the rule, use the rule right down. And now we are using sine rule. Okay, sine rule. Our sine rule is, we write down the formula first. This one, sine alpha over the opposite side, which is S2. Okay, or you can actually write down the value, but here we write the S2 must equal to this angle, sine 135 over this side here. You calculated already, 263. So if this one is wrong, your next answer will be wrong as well. So we have this our value here, so we should put in now. Okay, so our sine alpha over 80 is equal to sine 135 over 263. So we see what is our alpha value. Okay, so now our value is 80 multiplied by sine 135 and then divide by 263. Okay, that is 0.21. We take the arc sine, we have this, that will be 12.4 degree. Okay, 12.4 degree. All right, so that is our question number 1. Magnitude is 263 and angle is 12.4 degree. Okay.